NASA's rovers on the surface of Mars are revealing answers to some of the biggest questions about our nearby planetary neighbor. And driving this rover, that is, on average, 225 million kilometers away from Earth, requires robust technology and years of development.
And back on Earth, over 33 million miles away, space roboticist Vandi Verma drives the rover right from her desk at JPL.
So I'm Vandi Verma, and I drive rovers on Mars.
Well, guess what? I have my license on me. Do you think I could try out driving the rover?
Well, it might take just a little bit more training than that.
Vandi Verma is a natural-born trailblazer.
I really love adventure and exploration.
She constantly looks for new discoveries to make and obstacles to overcome. From climbing mountains to flying planes to her job as rover driver at NASA.
I've always loved exploring the environment I was in, and the rovers allow me to explore another planet.
Humans may be decades away from visiting Mars, but Vandi gets a first-hand look at the red planet every day she goes to work. Vandi began dreaming of this interplanetary adventure back in 1997, when NASA sent another rover, Sojourner, to Mars.
So when the very first Mars rover landed, I remember reading about it, and I was just amazed because it was such an amazing thing to do, to get a rover on another planet. And I was like, someday I want to work on that.
Her passion for out-of-this-world exploration traces back to her childhood in India.
I first became interested when somebody gave me this little book about space. And it was the first time I realized just how vast the universe was and just how different the various planets, even in our own solar system, was. And I wanted to see them. It seemed like a very remote possibility, but I never gave up hope for it.
The odds were stacked against her. Growing up in a traditional Indian family, Vandi was expected to follow her mother's wishes, to settle down and enter an arranged marriage with a nice Indian husband.
My parents have an arranged marriage, my sister has an arranged marriage. For whatever reason, it wasn't something that I was ready for.
Vandi dreamed of following a different path, inspired by her father, an Air Force pilot. Unlike her cautious mother, her dad encouraged her to take risks and seek adventure. After high school, she took her first big step. She moved to the United States and studied engineering at Carnegie Mellon University. But that didn't stop Vandi's mother from trying to arrange a marriage for her.
She would find people in Pittsburgh when I lived there. I was amazed, and they would call me.
Vandi dodged her mom's suitors long enough to meet classmate and fellow roboticist Paul Tompkins.
Like Vandi, I've been in love with space for as long as I can remember.
In 2005, they decided to spend their lives together.
We both love adventure.
They share a love for taking risks, but not chances.
It's very natural for me to take risk. At the same time, it's calculated risk.
So she has the element of adventure on one side, but then she's smart about it because she's not going to take a foolhardy risk.
She realized that this calculated risk mindset would also help navigate her new field.
I discovered robotics when I was at Carnegie Mellon, and instantly I knew this was what I wanted to do. Robots are incredible for exploring space or any areas where it's hard to send humans because we don't have to worry about survival, food and water.
While getting her PhD, Vandi headed to the Atacama Desert in Chile to hone her robot driving skills in its Mars-like terrain.
Atacama is a place where they measure rainfall in millimeters per decade. And that was a perfect place for us to take our robot and do an astrobiology experiment to look for life. My research focused on making sure that the robots could handle unanticipated situations.
This work caught the attention of NASA's Jet Propulsion Lab, who offered her the chance to explore the surface of another planet from a distance.
Space. Nobody knows how to get there better than the people at the Jet Propulsion Laboratory in Pasadena, California. Here, scientists work on the coolest stuff in the universe. They've built rockets. They've built robots. They've built a space phone that calls Santa. Just kidding. They don't have a space phone that calls Santa. I know because I asked.
Really, the center of the world when it comes to robotics is at Jet Propulsion Laboratory.
So she headed to Pasadena, California to join the Mars rover team and brought her motorcycle with her.
Mostly I used it as a commuting bike to get from home to work, but I'd always take the longest path possible and the most swervy.
Let's get to driving 101. What does it take to drive the rover in the first place?
In order to drive the rover, the first thing we do is we get images from Mars.
These are actual images from Mars?
Yes, these are actual images from Mars. And a lot of our tools process these images automatically and create a 3D terrain mesh that allows us to put the rover in that terrain.
The 3D images help Vandi avoid dangerous terrain and create the best path for the rover to take. Vandi also operates Curiosity's robotic arm, which it uses to take samples. To drive the rover, Vandi gives it a set of instructions to follow that the robot then carries out. Like if you gave a car a list of directions ahead of time and then it drove itself.
Even though the rovers do so much, the computing power we have on board is actually fairly limited. The average phone a person carries has far more computation than we have on board the rover. And the reason is because there's a lot of radiation. So we have to use computers that are radiation hardened.
There is no GPS on Mars. You can't just say, hey, this is this location, drive to that location. So just moving the rovers, there's a certain amount of risk.
And there's little room for error when driving on another planet.
Mars is a very dangerous place. It has very little atmosphere. The temperatures are incredibly cold. There are huge changes in temperature every day. So these rovers have to endure that kind of environment. They are solar powered, so if the rovers get too cold or if they get starved for energy, which is just the same way as a human being starving, they could die.
When you're looking at something, it's really hard to tell what the size might be, or if there's a ridge or a cliff or a crevasse there. So you want to look at it in 3D.
This is what these glasses are for, right?
That's exactly right. And then you put them on. We can see that there are rocks.
Whoa.
Look how much it pops out, and you can see that behind this ridge, there's another ridge, and there's actually a gap here.
I see it. This is wild. I'm looking at the Mars rover right now, traveling on this really rugged terrain.
With Opportunity, we were coming across sand a lot more on Mars. We had a situation where the rover was driving along, and by the encoders, as you measure, it's thinking it's covering all this distance, and it kept on moving, but it's just embedding itself deeper and deeper and deeper.
Since some of the most interesting places are the hardest to get to, the rovers constantly face the danger of getting stuck. And the drivers brainstorm different ways to get them out in a replica of the surface of Mars called the Sandbox.
There isn't one obvious right way to think. You want to explore the options. So the Sandbox is a great way to do that because you have one chance on Mars, but in the Sandbox, you could reset and say, well, that didn't work. Let's try a different strategy. You may choose to drive forward. You may choose to try to do it with a slight turn, an uphill turn, or drive backwards, maybe wiggle the wheels in order to loosen the terrain up. Once we figure out what solution works best, then we do it on Mars with that one chance we have on Mars.
Okay, so let's talk to us about that. What is your real mission on Mars? What are the next steps that we can expect?
So our real mission, we are going to Mars. We're looking for signs of ancient microbial life. We've landed in Jezero crater as we had planned because it's a delta, an ancient river delta, and so we'll be exploring the delta and then climbing out towards the crater rim. And we're collecting cores. That is one of the main things we're doing with this mission, which is new, is that we will be able to return the samples that this mission caches with a subsequent mission. And that'll be the first time that we ever get Martian samples back to Earth. And the incredible thing that allows us to do is use all of the science laboratories and facilities all over Earth to be able to study them. That's going to happen sometimes in the 2030s, and some of the technologies that we'll be able to use to study them, they haven't even been invented yet. So that's very exciting. It's that excitement that leads people to go ahead and do even more exciting missions for the future. Opportunity, one of the rovers that I drove earlier, it lasted so long that by the time the mission was done, some of the people who watched it land who were in high school actually worked on the mission subsequently. So, given how long it'll be by the time these samples come back, the students who are watching, they could be the ones working and analyzing those samples someday.
And perhaps the most exciting step will be bringing extraterrestrial samples back to Earth.
And once we get that sample on Earth, it's going to be quite incredible. And then they will actually be sent to labs all over the world. And it'll probably be decades that they will be analyzing that. After we land, we're going to deploy this helicopter, which fuselage is the size of a softball, and it'll fly for short durations and it's solar powered, and we'll be able to get data from it. So this is the first time we've had a helicopter on Mars, and that'll be really exciting as well.
The rovers have detected signs of past water. We've detected minerals that show that there was water.
And since water is the elixir of life as we know it, these findings suggest fantastic possibilities.
What the rovers have found is that Mars at one time was much more like the Earth than it is today. And this is very exciting and very intriguing, because if it was like the Earth at a time when life started on the Earth, did life start on Mars, or is there life there today?
Whenever you see some sort of a discovery made by the rovers, you sort of feel that you helped them along. It is a little bit parental feeling that, hey, I'm proud of that rover.
And like the rovers she drives, Vandi continues to create her own path and make new discoveries.
When I was growing up, I always thought it would be really cool to work in space, and it just seemed so impossible because everything that was going on at that time was halfway across the world. And now, when I do look back upon it, it is very amazing to think that, wow, I am very fortunate to be able to live what I dreamt about.
You can see this is just dotted with locations where we've done sampling and study.
How long did it take for the rover to come from this point to this point?
So we landed on August 5th, 2012, and we've covered about 20 kilometers, which is about 12 miles.
I can't imagine driving that distance here on Earth and it taking that long.
Unless every step of the way, there was something that you had never seen before, and you wanted to stop and check it out.